Hello, algebra class. This is the second lesson of the week. The lesson today is lesson 38, simplifying expressions using the greatest common factor, or the GCF. The concept today, and this is actually, even though we're going the new concepts, this is not new, but it's just something that's very important. It's something that we should be taking some time to look at. So simplifying expressions that contain numbers often requires knowledge of prime numbers and factors. Recall that a prime number is a whole number that is only divisible by itself and 1. Some examples of prime numbers are 2, 2 because the only numbers that go into it are 1 times 2. 5 because, again, the only numbers that go into 5 are 1 times 5. 13 because the only numbers are 1 times 13, and 19 because the only numbers that go into it are 1 times 19. Okay, all whole numbers other than 1 that are not prime are composite numbers. So basically a number is either prime or it's composite. Alright, composite numbers have whole number factors other than 1 and the number itself. They can be written as product of prime numbers, which is called the prime factorization of a number. For example, 4, you can write it as 2 times 2. Okay, that means that 4 is not a prime number, it's a composite number, and it's written, when you break it down, it becomes 2 prime numbers, right? 2 times 2, 2 is a prime number. 6 becomes 2 times 3. 8 becomes 2 times 2 times 2. Okay, and there's different methods to finding the prime factorization of a number. The one that you're probably more familiar with, is the one I've used, is the tree. And here is the tree. There's other ways. There's this way, which is you just list the factors, 2 times 12, and then it gets broken down as 2 times, and this is 2 times 6. Then they would break down 6 as in 2 times 2 times 2 times 3. I like the tree because you sort of see where things are headed. 24 is the same thing as 4 times 6, and then 4 gets broken down into 2 times 2, and 6 gets broken down into 2 times 3. Another way is this table where you say, okay, 24, I divide by 2, I get 12. I divide that by 2, I get 6. I divide that by 2, I get 3. Okay, I divide that by 3, I get 1. And the factors are right here. 2 times 2 times 2 times 3. I prefer the tree, but any of these methods is okay. Alright, and like it says, it does not matter which method is used. The final product, however, must consist of only prime numbers. So you break it down as far as you can go so that no numbers can be broken down any further. Okay? Alright, so let's look at the first example. The first example is find the prime factorization of each number. 120. Okay, 120. So let's go ahead and we can jump to the tree, my chosen method. And 120 is the same thing as 10 times 12. Then they break down 10 as in 2 times 5. They break down 12 as in 3 times 4. And they break down 4 as in 2 times 2. And the last row is the prime factors. So it's 2, and they have 3 2's, so 2 times 2 times 2, and then 3 times 4 times 5. Okay, let's take a look at something. What we're going to do here, I will demonstrate, is there's more than one way to break this down. The important thing to do is to end up with the end. So, for example, let's say that we were to here's 120, and we're going to break down 120, but we're not going to start at 10 times 12. Let's start at 60 times 2. Okay, 60 times 2, we obviously can break 60 down further. 60 down, we can say that's 10 times 6, okay, and times 2, okay, Then 10 gets broken down in 5 times 2. 6 gets broken down as 3 times 2. And then 2 comes down. Okay? So we have, so our factors are 5. Oh, that's not very good. 5. Let's try that again. Okay. 5. We have a 2. We have a 3. We have another 2, and we have another 2. Okay? If you look, that's exactly what they have for their factors. Okay, list the factors. They have 2 times 2 times 2 times 3 times 5, or 3 2's, and then a 3 and a 5. And that's exactly what I have. So even though I didn't start with the same breakdown, I ended up the same place. And that's the key. So if you find yourself doing that, you might not, you might have it different than someone else. The key is to, at the end, did you have the same factors at the end? That's the key. Okay? All right. Let's look at example 2 here. Okay. Example 2. All right. Let's see here. Okay. All right. Well, they went ahead and do 924. Okay. All right. 924 is a good example because it's large enough to where you're not exactly sure what goes into it. However, if you are not sure, if it's an even number, like in this case it ends in a 4, you always can divide it by 2. Okay, you can break it down with 2. Alright, so that's what they did. They divided it by 2, and they got 2 times 462. This is an even number. So then they broke that one down, divided that by 2. That's why you have 2 times 2 times 231. And then once they got here, they said, okay, let's try 3. And they divided it by 3, 231. And sure enough, 3 times 77 gave you 231. So now they have 2 times 2 times 3 times 77. And obviously 7 goes into it. So they divided by 7 and they got 11. So here you have the prime factorization of 924. Okay? All right. Prime factorization can be used when determining the greatest common factor of monomials, which is the product of the greatest integer that divides without a remainder into these coefficients and the greatest power of each variable that divides without a remainder into each term. I'll show you what that looks like. Okay, so it says determine the greatest common factor of algebraic expressions. Example 2. Find the greatest common factor of each expression. We have 6a squared b to the third plus 8a squared b squared c. Okay, so what did they do? Well, they wrote out the factors of each. For 6, they broke down as in 2 times 3. Okay, for a squared, well, that's a times a. For b to the third, that's b times b times b. Same thing for 8. They said 8 is 2 times 2 times 2 times 2. And then they said a squared is a times a, b squared is b times b, and c is c. Okay. Then you find all the factors that are common. All right, and this is very important. Notice what they did here. I like this. This is they specifically wrote them on top. Oh, they wrote them on top of each other. Okay, so they wrote the 2 here for the 6a squared b to the third, and they wrote the 2 there. Okay, and then you have the 3 and then a 2. These are times. Okay. Then you have a times a, and then you have the b times b times b, and down here we have 2, and then a times a, and then times b, and then times c. Okay, so what they do is you circle things that are in common, like we have a pair of 2's. Okay, then we have, alright, there's 2 A's. We can circle both 2 A's. Then we have 2 B's. Okay. Alright, so what then is the greatest common factor is just one from each group. So greatest common factor is a squared, b squared. Okay, and let's see if I got it right. There you go. Each term has a factor of 2 factors of a, 2 factors of b, so the greatest common factor is 2a squared b squared. You see that? So I put the factors down, okay, on top of each other so you can see, and then you circle what they have in common. Alright? Okay, so let's look at cut. Okay, so here's another example. Okay, and I'll cover up the answer. So we have 8c. Okay, so this is what I would do. I would have 8, okay, c to the 4th, d squared, e. Okay, now 8 gets broken up into 4 times 2, and this is 2 times 2 times 2. Okay, a c to the 4th is just c times itself 4 times, like that. A d squared is 2d's, and e, like so. And then you would do that for the other one, for the 12. Okay, for the 12c, for the 12c to the 3rd, d 4th, e squared. Well, 12 is just 2 times 2 times 3. That's why they have these circled here. Okay. Then you have d to the 4th. So I would put, we have a c to the 3rd. So you write the 3 c's. Okay. And 3 c's get circled. And then we have d to the 4th. So d, and 2 d's get circled. And then we have 2 e's, and only 2 e's get circled. Okay, so the greatest common factor is here 4 c to the 3rd d squared e. Okay, let's see if I'm right. And there you go. See, 4 c to the 3rd d squared e. Let's see. There you go. 4 c to the 3rd d squared e. Sorry, my handwriting is not so good there. Alright, so let's stop there, and we'll pick it up in the next part of this lesson for example 3. Stay tuned.